All right, now we're looking at our second set of graphs. We did cover our first question on what a distance time graph is. Hopefully I got some practice in there on reading them and working with them through the math packet that I gave you. Here we have the velocity time graph, which is related to it. However, it is going to be plotting velocity over time and not distance over time. So time is going to continue to be our x-axis, but this time instead of having distance on our y-axis, we are going to have velocity. And I'm going to reiterate the importance of labeling your axis so I know which graph you're referring to and what graph we're talking about. So there are some little rules of thumb for velocity time graphs. In this case, a horizontal line, unlike your distance time graph, means the constant velocity. So the horizontal line actually um, relates to having a constant slope in your distance time graph here. In velocity time, a horizontal line means a constant velocity or no change in acceleration. A straight sloped line is a constant acceleration. So again, slope here is going to be acceleration as opposed to the distance time graph where slope was velocity. Acceleration is, again, it's going to be change in velocity over time. So how is velocity changing over time? If it is a positive slope, then I have a positive acceleration. This doesn't necessarily mean I'm speeding up, and it doesn't necessarily mean I'm slowing down either. If I have a negative slope, then I have a negative acceleration. This doesn't necessarily mean I'm slowing down. Most cases it will, but not necessarily. So here we go. We have our horizontal line on our velocity time graph. So this means constant velocity. Note how velocity is on my y-axis here, and it is at 1, 2, 3. Let's say that's 3 meters per second. And it is not changing. It is not going to 4 meters per second. It's not going down to 2 meters per second. It's staying at 3 meters per second as time goes on. So a horizontal line here means a constant velocity. Over here, we have a constant velocity as well. However, it's on the other side of our line. And this line is going to give us some direction because I do have some direction plotted here. Note how my last one also had it. Here my velocity was north. Over here I have south. So this is a constant velocity north, and this is a constant velocity south. Again, so I'm getting that direction in there because velocity needs it. If the object isn't moving, then its velocity is going to be 0, and it's just going to lie on your y-axis. This is your object at rest. It is not moving, therefore it doesn't really have a direction either, so it's not going north or south because it's not going. It's not moving. It is stopped. It is at rest. Let's see here. A velocity time graph has a positive slope, then the object is undergoing acceleration in a positive direction. So if v, or velocity, is positive, also the object is speeding up. If velocity v is negative, then the object is slowing down. So you got to pay attention on where on this y-axis v is located. It's in the positive areas, and it's going with a positive slope, then it's actually going to be speeding up. If it's in the negative area and it's going with a positive slope, it's actually going to be slowing down. Here we got one with a positive slope. You'll note that it is in the north area. My velocity over here will be positive numbers. I am having a constant slope, therefore I have a constant acceleration, and therefore my object is speeding up. Over here, I still have a constant slope, therefore a constant acceleration. It is still going upwards as you go left to right. However, it's starting in the negatives and it's getting higher, and therefore it is actually getting closer to 0 velocity, and therefore I have positive acceleration, but my object is still slowing down. So this here is slowing down as it encroaches this x-axis, sorry. As it's going away from it, that's speeding up. We can't have negatives, so again, I'll give you time to copy that down, but if v is positive, the object is slowing down, and if v is negative, then the object is speeding up in this case. So it's kind of the opposite of what's positive slope. So here's our graphs. With that, I have a negative acceleration because I have negative slope here. I have negative acceleration, I have negative slope here. However, up here I'm in higher numbers getting down to lower numbers here, all in positive velocity. So you can think of that as slowing down. And there my object is slowing down. Over here, I have the negative quadrant, but I still have negative slope. Therefore, I have a negative acceleration. Velocity is negative as well. And that is actually speeding up. It's just because the two negatives will make a positive, and therefore it is speeding up. Um, those are pretty much what you're going to see. You can get curves in these graphs, but we are not going to cover it. That is actually a measurement called Joule, and there will be an acceleration versus time graph depending on how far in physics you decide to go, and that will be discussed later. Another quick interesting thing is the fact that the distance over time graph is actually the derivative for the velocity over time graph. So if you get into calculus, you look at the slope of your distance time graph and you start plotting your slopes on another graph, you'll get your velocity over time graphs. So that's another interesting thing if you want to go further into the math and get into the calculus part of it. Eventually, physics does get pretty interesting in both cases.